Hey everybody, this is a video for my grade 10 Intro to Applied and Pre-Calc class, my MIAP class. And this is the second lesson in Chapter 7. The first lesson was 7.1 and 7.2, where we learned how to make a system of equations, and we learned how to solve them by graphing. Now we're going to move on to solving them purely by algebra. So we're going to use two methods. The first of the two methods we're going to use is called substitution. So here we have a system of two equations, two unknowns. So let's remember what exactly we're doing here. What we're doing is we're finding the one xy coordinate pair, right? The x comma y, where it's the same value for x and y in both equations. What we've done in the first lesson is we graphed the two lines, and where they met was the intersection point was the xy, the solution of the set. But now we're going to do it by substitution. So what I noticed is that there's a coefficient of 1 on this x. So I'm going to take the time to isolate this variable for x. I'm going to minus 2y from both sides. That cancels it on the left and moves it over to the right. Now I'm going to substitute this expression for the x in the other equation. So instead of 3x plus 4y equals negative 4, I'm going to replace this x with 2 minus 2y. And now, if you look at it carefully, you can see that that's just the kind of algebra you learned how to solve back in grade 9. It's just a linear equation now in one variable. So step 1, distribute through the bracket. Step 2, I'll collect the like terms. And step 3, minus 6 from both sides, and then divide both sides by negative 2 and we're done. Okay, now that's only the y coordinate. I still need the x coordinate, but notice I've got a nice handy little equation here that I can use for the x coordinate. Now that I know that y is 5, I substitute again, and I put the 5 in where the y was, and do a little bit of solution for that. 2 minus 10 is negative 8. And okay, so I think that the solution to this is negative 8, 5. So let's check and see if that's true. Now when I do a check, and you don't always have to do a check, but I want to make sure I have the right answer. Since this is the equation I did the majority of my algebra with, the first one, I'll use the second equation for my check. So negative 8 plus 2 times 5 had better equal 2. And is that a true statement? Well, let's see. Negative 8 plus 10 is equal to 2, so 2 is equal to 2, so yes, that's true. Now, notice I picked that equation. I could have used the other one. I could have used the other equation, 3 times negative 8 plus 4 times, and instead of y, I put in a 5. And remember, we called this in the last chapter satisfying the equation. The point that we found should satisfy both equations because it is the intersection point of the two equations. It's on both lines. So that's negative 24 plus 20 equals negative 4, and yeah, we can tell that's true. So yep, we have the right answer. It is x equals negative 8 and y equals 5. All right, second example. If that made sense to you and you're feeling fairly confident on how I did that, by all means, pause the video and give example 2 a try. Focus. All right. Do you get a solution? Let's see if you get the same solution I do. Same trick. I'm going to move this, or isolate this equation for x, and then plug that into the next equation for the x value. So that's going to be 4 times 35 minus 5y plus 2y equals 32. And let's see, that's going to be 4 35s. That's 120 plus another 20, so that's 140. And 20 plus 2y equals 32. So let's see, I'll collect the like terms. 140 minus 18y is equal to 32. And 32 minus 140, let me think about that for a second. Is that negative 108? I think it is. So negative 108. And I think actually 108 divides by 18. Let's see. 3 goes into 108, and 6 goes into 108. So yes, it does go in. So let's see, maybe I'll use a calculator to help me, so just to make sure I don't goof this up. Since 18 is out of my times table, it is 6. So y is equal to negative divided by negative is a positive, so I'll get 6. And so I think that the solution is y is 6. I'll go back and plug that 6 into here. So really there's no difference between example 2 and example 1 except that the numbers got bigger. So that's 30, oops, that's 35 minus 30. X is 5. So I think that the solution is the point 5, 6. Once again, just to make sure I did this right, I'm going to plug this in, and since I use that equation here for most of my algebra, I'll use that one for my verification. So 5x plus, or 5 replaces x, and 6 replaces y, and does that equal 35? So this is my check, and yeah, 5 plus 30 does equal 35, check. So yep, therefore 5, 6 is my solution. Okay? And you do write it as a coordinate. Make sure you put it in brackets as a coordinate. The other way you could write the answer is to actually write out that x equals 5 and y equals 6. Okay? Both of those are acceptable. Don't just write 5, 6 without a bracket, though. Okay? That's example 2. For example 3, okay, little bit, oh, there we go, example 3. A little bit tougher. I'm going to use a little more advanced strategy. Check this out. Notice that neither of these equations have just an x or just a y. They all have coefficients that aren't 1 in front of them. Notice that this equation here, 4, 6, and 8 are all even. So I'm going to divide both sides of that equation by 2. You can do that. You can simplify an equation the same way you simplify a fraction. That is the same equation. I haven't changed anything about it. The x and y still have the same values. But now, check this out. Notice that I could take this equation and simplify it for negative 3y. So negative 3y is equal to 18 minus 5x. Correct? So I could substitute 18 minus 5x for that 3y. And just to show you that you don't even have to do a simplification like that. You could even do one more step. You could simplify this equation, or simplifying is not the right word. Rearrange this equation by isolating for negative 3y. And this is also substitution. Now I'm kind of substituting them both. Basically what I'm saying is this. In this equation here, since negative 3y is equal to this thing, and in this equation here, where I turned it into that, negative 3y is equal to that thing. Well, if both of these things are equal to negative 3y, then both of those things should equal each other. Isn't that cool? So now I have one equation with just x in it, so I'm going to, let's see, I'll add 2x to both sides, and I'll minus 18 from both sides. So x is equal to 3 is the x coordinate of my solution. To find the y coordinate, I'll plug it into here. So negative 3y is equal to 9 minus 2 times 3. Negative 3y is equal to 9 minus 6. Negative 3y is equal to 3. Y is equal to negative 1. So I think that my coordinates of my answer are 3 and negative 1. And I did I did all my algebra with both equations, so it doesn't matter which one I pick. I'll pick the one with the 4 in front. So for my check, I'm going to use the 4 equation. So 4 times 3 minus 6 times negative 1 is equal to 18. So that's 12 plus 6 is equal to 18, which is true. Now, a lot of people find that when they're doing these, it's this part where things go wrong. And if your check turns out wrong, well, number one, make sure you did the arithmetic right. You have to be good at arithmetic to do a check properly. But if you're very sure the arithmetic's right, you plugged in the numbers in the right place, that means there's something wrong with your solution. You have to go back through your algebra and find your mistake. Okay, so if you get two things that don't equal each other in a check, this is not the right answer. Okay, assuming you did the arithmetic right in the check. So that is the substitution method, where I substitute something in the equation with something it's equal to so that I get equations down to a single variable and then solve them. The other method also asks you, or uses the same logic. You have to get down to an equation with just one variable. But we do it differently here. This time we do it by what's called elimination. Sometimes this is called the addition-subtraction method, because you're literally going to add and subtract equations from one another. Here's my example right here, example 1. These two equations both have just y in them. Again, I could go back to method 1 and I could just move the 2x to the other side, make it a negative, then plug in -7 minus 2x where this y is. But we're not going to do it that way. What we're going to do is we're actually going to take these two equations and subtract one of them from the other. And it helps if I copy it right. And I made a mistake there too. There we go. There. So I am subtracting this entire equation from that one. Now, remember when you're subtracting all of it. So it's 2x minus x, which is x. It's y minus y, which is nothing. And that's what I wanted. Remember, I wanted to eliminate one of the variables. Now, careful with the last part. It's -7 minus -4. What happens when you minus a negative? Correct. So I think x is 11. I'll plug that 11 into this equation. So 11 plus y is equal to -4. Minus 11 from both sides. And I get that. So I think the solution to this equation is 11, -15. Better check that out and make sure I did that right. So since I did this, I used this equation for the substitution. I'll use that equation to check them both. 2 11s add -15 should equal -7. That is, something is wrong. 2 times 11. Oh, well. Look at that. See? My check told me that my algebra was going wrong. What did I do? Can anybody see what I did wrong? -7 minus -4. I told you to watch that. My God, that's way off. Let's try that again. -7 minus -4 is actually -3. That means, oh, I gotta fix all kinds of things. So that means I gotta fix this. -3, and that means that -4 add 3 is -1. This is way off. So that's -3 comma -1. That's better. And let's do the check again with the right point. Okay, so I think x is -3 and y is -1. So 2 times -3 add -1 should equal -7. And that's actually working now. -6 minus 1 does equal -7. That's true. You know what? Just to make sure, since I did goof this up the first try, I'll try the other equation too. X plus y is -4. X plus y is -4. Yep. I am 100% sure that that's the right answer now. Okay. Let's see if I can avoid mistakes on the next one. Example 2. Let's eliminate here. Okay, problem. If I subtract these two equations from each other, I'd still get an x and a y. I didn't eliminate anybody. But remember, this happened a couple of examples ago. I can multiply both sides of this equation by a number. I'm actually going to multiply both sides of the equation by -2. So that means the first equation is going to stay the same. But the second equation is going to turn out to be -2x minus 12y equals -20. Don't forget you're multiplying both sides of the equation by -2. So that got multiplied by -2, that got multiplied by -2, and that got multiplied by -2. And now it looks like this equation. And now I just add those equations together. 2x add -2x is nothing, which is the point. I've eliminated one of the variables. 5y's add -12y's is -7y's. And 13 add -20 is -7. Divide both sides by -7, and I get 1. Go back to, I'll go to this equation. X plus, I think y is 1, so I'm going to plug in a 1 there, is equal to 10. X plus 6 is equal to 10, so x is equal to 4. So I think that the answer here is 4, 1. Let's do a check and make sure that's right. Since I played with this equation in the second place, I'll use that equation now. 2 times the x is 4, plus 5 times the y is 1, has to equal 13. Is that a true statement? Does 8 plus 5 make 13? Yes, it does. So I'm 100% confident I have the right answer. Okay, example 3. Once again, we'd like to solve by elimination. What are we going to eliminate this time? Well, here's the thing. Unless I wanted to times this equation by 2.5 and then deal with decimals, I don't know how I get x to be a 5. And what would I times 3 by to make it a 4? I guess I'd have to times it by 4/3, which is an even uglier fraction than 2.5. So I am going to actually multiply both of these equations by something. I'm going to multiply this equation by 2, and I'm going to multiply this equation by 5. So when I multiply this equation by 2, I get 10x plus 8y equals 12. And when I multiply this equation by 5, I get negative 10x minus 15y is equal to negative 5. Now I can add those equations together. The 10x and the negative 10x completely cancel. And then 8y's minus 5y's is negative 7y's. And 12 add negative 5 is 7. So y is equal to negative 1. Okay, I got to figure out what x is now, so I'll use the second equation. Negative 2x minus 3 times negative 1 is equal to negative 1. So negative 2x plus 3 is equal to negative 1. Negative 2x is equal to negative 4 when I minus 3 from both sides. So x is equal to 2. So I think the answer is 2, negative 1. Let's do a check and see if I did that right. So I'll pick the first equation. 5 times 2 plus 4 times negative 1 had better equal 6, or I goofed something up. 10 minus 4 is equal to 6. Looks good. So there we go. That is the substitution and elimination methods for solving two equations with two unknowns, aka a system of two linear equations. Really, at this point now, it all comes down to practice. I've done this stuff for 30 years. I've done a million of them, and notice I still goofed one of them up because I wasn't paying attention to what I was doing. So practice, practice, practice is what you got to do now, guys. So the next assignment is going to feel like a whole bunch of homework, but you have tomorrow and the whole weekend to do it, and even Monday I'll probably just do something a little lighter, and you don't necessarily need to do a whole bunch of homework on it. So over the next few days you need to practice this a whole bunch. Okay, thanks for watching, everybody. See you later.